My name is Charles Green. I'm going to be talking to you about motor controls and in particular about motor starters. Um, when I'm out doing electrical work, one of the first things that I want to be able to do is get a piece of equipment back up and running as fast as possible, because number one, it's going to be saving the customer money. It's going to be making more money for me, because I'm going to get a minimum for going out and doing a call out, for example. If I can do that job in 2 minutes, or it takes me 2 hours, um, I'm going to get the same amount of money. So basically, if I can take care of something in 2 or 3 minutes, then I'm saving them money because I'm getting them operating faster, and I'm making more money for myself. One of the first things that I'm going to be doing when I go out to a piece of equipment, motors are going to be protected by a motor starter. So one of the first things that I'm going to look at to make sure that I'm getting voltage to my piece of equipment is to check to see if the starter's pulling in. And if the starter's not pulling in, I'm going to ask myself why. Why do I not have voltage going to that piece of equipment? The first thing that comes up when I go in, I'm going to check to see if my overload is tripped. If the overload's tripped, it may be as simple as just pushing the button, and then of course I'm going to find out why it tripped. I'm going to check the amps on the piece of equipment. So as far as we're going here, checking the overloads is the first thing that I'm going to do. Once we do that, if it's not pulling in, the next thing I'm going to look at is the coil voltage. Am I getting coil voltage to it? So I'm going to check the coil to see if I got voltage to it. If I got 120 volts or whatever the coil voltage is, I'm going to check to see if that voltage is present. If it's present, then I'm going to disconnect the power and read continuity through those coils to see if I've got a problem with the coil. All right. Number three, I want to ask a question. What's the purpose of a motor starter? The purpose of a motor starter is for protection of the motor. The most important thing that I want everybody to keep in mind in working with controls, the most important thing is going to be safety. I can tell some stories about arc flashes, and for example, I bypassed all the controls, turned the power on to check out a problem with the motors, and had an arc flash that basically blew up in my face. Okay, so safety is the number one issue. We've covered safety quite a bit in electricity, and for me, the idea of having a great amount of respect for electricity is the key to being able to go out and do the next job. The person that is going to be doing the work on these motor controls, or any kind of electrical work as far as maintenance goes, the definition according to the National Electric Code is a trained person. Not necessarily a master electrician, but at least somebody trained in servicing that piece of equipment. When checking the overloads, the first thing that I'm going to do is, like I said, is push that button. Now, the overload is going to be a set of normally closed contacts, and sometimes even after I push the button, I'm going to double check myself to make sure that I've got continuity between the overloads. So if I've got continuity, I know my overload protection is there, and I should be getting a neutral up here to my coil. So if I've got the neutral going to my coil and I've got voltage going there and it's still not pulling in, that's going to tell me right away that it's going to be the coil just needs to be replaced. All right. The next thing that we'll look at is the heaters. On this particular model of starter, I've got 3 heaters, and depending on the make of the motor starter, they may look a lot different. But one of the things that'll happen is whenever we start pulling too much current, I'll burn one of these heaters in two, and so I'll lose continuity between this, causing that motor to single phase. Once it single phases, that's going to increase the current, and that's going to cause the overloads to trip. It'll open up the set of normally open or normally closed contacts there. So the heaters are sized based on the horsepower of the motor. All right. True or false? The coil on the motor can be changed depending on the requirements or the voltage that's present. Okay, the control voltage may be 24, it may be 12, it may be 120, or even some other number depending on the voltage that's current. Normally I like to use 120 volts. When I'm building a panel myself, I'll use 120 volts for everything. So the coil voltage for this starter can be anything. So one of the problems that I've seen with a lot of my students in the past is they'll grab a coil and put it in a starter, and it'll be the wrong voltage, and then they end up burning the coil up. When checking the line voltage, one of the other things that I've had people do is I want you to be able to check from phase to phase, and then from phase to ground on each one of those phases to verify that I've got current coming through all of them, or I've got voltage coming through all of them. You know, I've gone out on jobs before, and it just take 2 minutes and be able to tell the customer when I was done, because somebody else had been in there working for days and couldn't fix it, and there would be a schematic on the door, making it simple. What I want my students to do now and always is to be able to think for yourself and be able to try to understand how each piece of equipment works. If we can do that, we'll be able to troubleshoot in a rapid manner, and it's going to make the students and the employee look better and be able to be more productive for the customer and themselves. Thank you for your time.